Good afternoon, viewers. Welcome to MouShauk. So today I'll be discussing the general trends in the modern periodic table, some of the characteristics of the periodic table, which will denote the trends in the periodic table. Okay, and along with it, uh, there are some uh, groups which I will discuss, which are present in the modern periodic table. Okay, groups and periods, which we will discuss. Okay, so let us start with. Before I start, I will request you to please do subscribe my channel if you have not subscribed yet. And if you are a new viewer to my channel, please do subscribe it and ring the notification bell because that will notify you as soon as a new video is uploaded. And if you are liking the videos, press the like button, share with your friends so that they can also be benefited from these videos. And do not forget to meditate before you start your day. So for meditation, let us concentrate on the point of light. Think that light is falling on you. Okay. And that light is falling on whole of your whole body. Whole of your body is being enlightened with that light. You're getting energy from the light and you are becoming happy and energetic, getting interest in whatever job you are doing. You're doing it very happily, joyfully, and finishing it in very successful way. You're getting appreciation from everybody, and the least but not the, I mean, the last but not the least is that you are thanking God for getting such empowerment from Him. Okay? So, thank you. Thank you for joining this celebration. And now let us come back to the discussion. Okay? So the general trend in the modern periodic table. In my last video, I discussed about the merits and demerits of the modern periodic table. So what we can know the electronic configuration, which is, as we know, that these type of this modern periodic table explains the periodicity of the properties of the elements and it relates to the electronic configuration. Okay, so this type of compounds formed by this element can be predicted. What type of compounds can be formed by these elements can be predicted from their position in the periodic table, which because it is related to their electronic configuration. Okay, the classification of the elements is based on the atomic numbers, which is their fundamental property, and the isotopes. The elements which are having the isotopes, they are placed in one place, and that is justified as the classification is based on the atomic number and not on the atomic mass. Even the lanthanides and actinides, they are placed separately, which are placed at the bottom of the periodic table and not included in the main periodic table. Okay, the table is simple, that is systematic, and it's an easy way for remembering the elements position. Okay, now what were the demerits? That is defects. Defects were that the position of hydrogen was not certain. It should be placed in 1A or 7A, that is not confirmed. Okay, so there is no place for isotopes of the elements in the modern periodic table. Even the lanthanides and actinides, they're placed separately and not kept in the within the main periodic table. That's a defect for the modern periodic table. Then the table could not explain the cause of the periodicity. Why the periodicity is happening, the table is not able to mention that, or how the separation, the similar elements, why similar elements are being separated, that is also being not explained properly. Now, some dissimilar elements have been placed together. That is also been a defect of the modern periodic table. Now we are coming to the trends of the periodic table. Okay. So modern periodic law, it is based, we know that the periodic trends of the properties of the elements in the modern periodic table. Okay, so modern periodic table is the base. It is the base on which the periodic trends of the properties of the elements are present in the modern periodic table. Okay, which will, that is modern periodic law explains why there is a periodic trends of the properties of the elements. Okay. Now, the following properties of elements show a very clear periodic trend in the periodic table. What are the properties which we consider it, which will tell the periodic trends? Okay, the properties of the elements. Okay, so what were those? The number of shells and valence electrons, valency, properties of the elements, atomic size, and metallic character. Okay, so we first move on to the number of cells and valence electrons. Okay, so number of shells increase down the group. That is, when we go from top to bottom in any group. Okay, in the periodic table, that is, just see the picture, first picture. So from top to bottom, as we are going, the number of shells increases. Okay, just see the arrow, it is going down. So from top to bottom, when we are going down, arithmetically, the number of shells increases. Okay, the number of valence electron is the same within the column and increases left to right within a row. But within a column, that is within a group, the number of valence electrons are same. Okay, number of valence electrons are same. For example, see in the group 1, all the elements have same valence electrons, that is 1. For the group 2, we have 2 valence electrons, same throughout the group from top to bottom. The shells, number of shells increases, but valence electrons remains the same throughout the group. But the valence electrons increases when we move from left to right. That is from group 1 to group 7 or group 8. When we are moving, we see that valence electrons increase in number. Clear? Within a row, that is within a period. Now, from left to right in a given period, the number of shells remains the same. Okay, so from left to right, when we are going through within the period, same period, that is within a same row when we are going, from left to right, the number of shells remains the same. But the number of valence electrons increases. Okay, similarly, it's just the opposite in the group, that is when we are moving from top to bottom, the valence electrons remains the same, but number of shells increases. I'm clear now? Okay. Next, we move on to the valency. Now, valency, we know it is the combining capacity of an atom or the number of electrons which are present in the valence shell. That we know, that's the definition of valency. It is the combining capacity of an atom or the number of electrons which are present in the valence shell. Okay. Now, this valency, what is the trend of this valency? Across the period, that is when we are moving in a row from left to right. Okay, from left to right, then we see that the valency increases, then it decreases. First it increases, then it decreases. Okay, the valency first increases and then it decreases. This happens across a period, that is when we are moving in the same row from left to right. Clear? Now, across the group, what does it happen? Excuse me. There is no change in the valency across a group. That is, from top to bottom when we are moving, the valency remains the same. Same valence. Okay. Now, the valency of a particular element is determined by the electrons which are present in the last shell, that is in the valence shell. Number of electrons present in the valence shell, that determines the valency of that particular element. If the number of valence electron is less than or equal to 4, if it is less than or equal to 4, valency is equal to the number of valence electrons. Less than or equal to 4, then the valency will be equal to the number of valence electrons. For example, if an element has 2 valence electrons, so first let's say that it has 1 valence electron, so its valency will be 1. If it has 2 valence electrons, then valency will be 2. If it has valence electrons has 3, it has 3 valence electrons, then the valency will be 3. If it has 4 valence electrons, then the valency will be 4. Okay, clear? Now, if the number of valence electrons is more than 4, then what happens? Valency will be equal to 8 minus the number of valence electrons. Okay, so why 8? Because we need to form an octet to complete the valence shell. Okay, any shell to complete the valence shell, it has to complete, it has to make 8. It has to have 8 electrons on its valence shell to form the octet, or in case of helium, only 2 electrons. Okay, for forming the duplet. Okay, now in case of, as we know that we have to form the octet, so the valency will be if the element has more than 4 valence electrons. Therefore, its valency will be octet, that is 8 minus say 5. If the element has 5 electrons in its valence shell, so the valency will be 8 minus 5, that is 3. Okay, or if it has 6 valence electrons, then 8 minus 6, that is 2, will be the valency. If it has 7, like chlorine, then 8 minus 7, that is valency will be 1. Am I clear? Next. See, this is the thing. Valency of group 1A elements is equal to 1, group 2A elements is equal to 2, group 3A elements is equal to 3. Why group 13? Okay, so 13 minus 10, that is 3. Okay, so 4A, 4. Okay, 5A will be 3. Why? Because it's 15 group. Okay, 15 group has 18 as the valence electron. So 18 minus 15, that is 3. Okay, then group 6A, 16, group 16, you can say these 6A is a subgroup. Okay, A1A, 2A, 3A, these are all the subgroups. Actually, they are belonging to group number 1, group 2, group 3, group 4, okay, group 5. So group 3A belongs to group 13, group 4A belongs to group 14, group 5A belongs to group 15, group 6A to group 16, group 7A to group 17, and there is a valency of group 0. There is also a group 0, which is group number 18, which has no valency because it forms an octet. Its total valence shell is complete. Okay, that's why it has no valency. That's why it does not react with other elements. And that is why those elements are known as inert gases. Okay, noble gases or inert gases. Okay, so group number 13 has a valency 3 because 13 minus 10, that's 3. 14 minus 10, that is 4. 18 minus 15, that's 3. 18 minus 16, that's 2. Then 18 minus 17, that's 1. Okay. Next, we move on to next section, that is just a second. Properties of the elements. These are the properties of the elements. Now, elements in a given group have similar electronic configuration. In a same group, that has similar electronic configuration. Okay, as the number of electrons in the respective outermost shells is the same, that is, they have very similar physical and chemical properties which change uniformly down the group. So what happens in a given group? It has similar electronic configuration. Therefore, the number of electrons in the valence shell, that is outermost shell, that is same. Okay, like in group 1, the valence electron is 1. So the valence electron is 1. The outermost shell has 1 electron. Okay, therefore their electronic configuration is also similar. Therefore, they have similar physical and chemical properties that change uniformly as we go down the group. Okay. Now, alkali metals, that is group 1A elements, they are all very reactive, and the degree of reactivity that further increases when we go down the group. For example, see, lithium is reactive, but that sodium is more reactive than lithium. Potassium is more reactive than sodium. Rubidium is more reactive than potassium. Okay, and cesium is more reactive than rubidium. Like this, it increases, the reactivity increases. Now, halogen atoms are also very reactive, but their reactivity decreases from fluorine to iodine. Okay. So in case of halogens, their reactivity, when we move on to fluorine to iodine, its reactivity decreases. That is, fluorine is more reactive than fluorine. In the this indication will be just the opposite, because F will be more reactive than chlorine, chlorine will be more reactive than bromine, bromine will be more reactive than iodine. Iodine is the least reactive atom. Okay, element, sorry, it's an element. Iodine is the least reactive element in the group of halogens. Okay, now as in a period, the number of electrons in the valence cell changes. Okay, properties of the elements in the period differ significantly. Reactivity first decreases till group 14 and then it increases. So in group 1 elements are the most reactive metals, but those of group 17 are the most reactive non-metals. Okay, so what do we see? In case of period, till then we were discussing about groups. Now we come to periods. See, periods, in case of periods, we see that number of electrons, we know that it increases in the case of, the number of electrons in the valence shell changes. And down the group, the valence shell remains the same. The number of electrons in the valence shell remains the same. But when we come to periods, the number of valence electrons, that changes. So therefore, properties in the period, that also differ significantly. Okay. And first, in this case, the reactivity first decreases down the group till group number 14, and then it increases. Okay. So what do we see in group 1 elements, the most reactive metals, and in case of group 17, when we move on to group 17, they are most reactive non-metals. Okay. So from metals, it is becoming non-metals as we move from left to right. Now we come to atomic size, or we can call it as atomic radius. What is that? It is the distance between the center of the nucleus of an atom to its outermost cell. From the nucleus of an atom to its outermost cell. So if it is the nucleus and this is the shell, this is the outermost shell. So the distance from here, this is the center, from here to here is the radius, or atomic radius, or atomic size. Okay. Now, on moving from top to bottom in a group, the atomic size gradually increases, because we know the shells, number of shells increase. So therefore, the atomic size gradually increases, and atomic number increases down the group. Why? Because why the number of shells increases? Because the atomic number increases. Number of electrons are added more. Okay, so as the atomic number increases, number of shells increases and the atomic size also increases. Clear? From when we are moving from top to bottom. Now, in a period, when we are moving from left to right, the atomic size gradually decreases. Why? Because the atomic number of the elements increases while moving from left to right, but the number of shells in the elements remains the same. Okay, atomic number increases when we are moving from left to right, that is okay. But the number of shells, that remains the same when we are moving from where? From left to right. That is in a row, in a period. This we are considering about the period. We are talking about the period. First point, we were talking about the group, where the number of shells increased, atomic number increased, number of shells increased, and atomic size increased. But in case of period, number of shells remains the same, though atomic number increases. Clear now? Why this happens? This is because atomic radius decreases with the increase in the number of protons, thereby increasing the nuclear pull. Atomic radius or atomic size, you can say, that decreases with the increase in the number of protons. As we know that atomic number increases. So atomic number is what? Atomic number is number of electrons or number of protons. So number of protons, as the number of electrons are increasing, number of protons are also increasing. And when the number of protons are increasing, what happens? There is a nuclear pull. Nuclear pull also increases. So that will decrease the atomic radius. That's why the size of the atom, that decreases down the period from left to right. Not group, but from left to right. Clear? Noble gases show exceptional behavior. But in case of noble gases, this is an exceptional. What happens here? The atomic size of the inert gases, not intergases, it is inert gases, suddenly increase as compared to its predecessor halogen atom. So before inert gas group, that is the 0 group or group number 18, there is the group number 17, that's the halogen group, group 7A, that is the halogen group. Okay. From the halogen group atoms, that is elements which are present in the halogen group, those elements, the atoms of those elements are smaller than the noble gases atoms. Here, suddenly the size increases, the atomic size increases. This is why, because the noble gases has completely filled outer and inner shells. The noble gases, they have fully filled outer and inner cells. So a repulsive force occurs between the electrons, which results in the larger atomic size compared to the halogens. Here what happens? The noble gases, they have all the cells, that is outer and inner shells, all are filled. And as they have all the cells filled, there is a repulsive force between the electrons, and which results in the increase in the size of the atoms compared to the halogens. Clear? Next. See, this is the, this is slightly blurred, the picture is, but see, atomic size down the group, it increases. When we are moving from left to right, it decreases. Okay. When we are moving from left down to right top, there is a decrease in the size till 17. Then group number 18, suddenly there is an increase in the atomic size. Okay. Here, see, atomic size decreases, atomic size increases down the group, and from the period, across the period, it is decreasing. Okay. You can see from the picture also. See, lithium, then sodium, then potassium, then this rubidium, and then cesium. This size, atomic size increases. Then we are moving to from left to right. You see down when we are moving from 1, 2, 3, 4, 5, 6 is the group when we are moving. Let's see the size, atomic size just decreased. Okay. Now we come to metallic character of the element. Now, when we are moving across a period, while moving when from left to right across the period in the periodic table, the metallic character of the element decreases as atoms more readily accept electrons to fill the valence shell than lose them to remove the unfilled shells. Okay. So when we are moving from left to right, their metallic character decreases down the across the period. Okay, across the row. Okay, why? Because the atoms tend to accept electrons to form the octet, to fill the valence shell. Then they lose them to remove the unfilled shell. Like in case of the first group, the elements, they lose electrons. The atoms, they lose electrons to unfill their shell, from their unfilled shell to form the to show that they have a metallic character. Metals, they lose electrons, okay, and non-metals, they accept electrons. So the metal, the group 1, group 2A, group 1A, group 2A, they lose electrons to show their metallic character. But as we move on towards the group 17, 13, 14, 15, 16, 17, they accept electrons. Okay, so this metallic character that decreases across the period. For example, see elements of the second period, lithium, beryllium, they are metals. Boron is a metalloid. Okay, and then carbon, nitrogen, oxygen, fluorine, these are non-metal. Neon is an inert gas. Okay, so the metal, gradually it becomes non-metal. From metal to metalloid, then non-metal, and then gas. Okay, then oxides of elements, while moving from left to right across the period, okay, becomes progressively less basic, finally change to acidic. Okay, so when we are moving from left to right across a period, the oxides of the metals, oxides of the elements, they become less basic. That is, from basic character, it becomes acidic. For example, see oxides of the third period, that is sodium oxide, magnesium oxide, aluminium oxide, silicon oxide, phosphorus pentoxide, sulfur trioxide, chlorine oxide, all these chromic, they will lose their acidic character. They will lose their basic character and become acidic. Okay. Then across the group, this was happening across the period. Now this metallic character across the group, what happens? That is when we are moving from top to bottom in a group. Then the metallic character of the element set increases as electrons become easier to lose. Because the atomic size is more, their last valence shell, that is away from the nucleus, their attraction from the nucleus is much less. They will lose their last electron, valence electron, very easily. Therefore, the more we go down the group, their metallic character increases. Less attraction is there between the nucleus and the valence electrons. Okay, and that's why this distance between them increases, and they will lose electrons very easily. So in case of, see, nitrogen, phosphorus, they are non-metals, arsenic, and Sp, that they are metalloids, and bismuth is a metal. Okay, group number 15. Then oxides of elements. While moving down the group, the basic character metallic oxide increases. That is, when we are moving down the group, from acidic, it changes to basic. Okay. Then nitrogen dioxide, potassium pentoxide, phosphorus pentoxide, these are acidic. Arsenic oxide, that is amphoteric, Sp2O3, and bismuth Bi2O3, these are all basic. Okay. Now we come to placement of hydrogen in the periodic table, where it has been placed. Generally, in the periodic table, hydrogen has no fixed place. Okay, it can be placed with the alkali metals in group number 1, or it can be placed in some with halogens. Why it has been placed with the alkali metals? Because the electronic configuration of hydrogen is very similar to that of the alkali metals, to those of the alkali metals. That's why it can lose, it can lose one electron to form H plus simply, like the alkali metals. Okay, so they are having one valence electron. But due to its very small size, so hydrogen is very small size, so due to its small size, many of its properties are very different from those of the alkali metals. So while discussing the alkali metals, hydrogen is ignored. That's why we don't mention hydrogen when we are discussing about the alkali metals, because it's very small, it's too small. Because lots of properties of the alkali metals are not present in case of hydrogen due to its smaller size. Whereas hydrogen atom also resemble halogens. It also resembles halogen, and that's why they are present in the they are present in the 7A group, okay, with the halogens. Now, alkali metals, they produce hydrides like halogen. Okay, lithium hydride, sodium hydride, lithium chloride, sodium chloride, like that. So, alkali metals, they produce hydrides like halogens. The electrolysis of hydrides produce hydrogen, and electrolysis of sodium chloride that produces chlorine. Okay, so very similar properties with the halogens. In addition, hydrogen can gain one electron. Like in the first A group, like the alkali metals, it will lose very easily. It loses one electron to form up one positive ion. Okay, here in case of halogens, very similar properties with the halogens. That is, it will gain one electron to form what? To form a noble gas configuration. It will form one electron to form a negative ion. One negative ion. Okay. Now, because of its resemblance to the halogens and alkali metals, its position is still not fixed. In some periodic tables, it is not placed in any group, but placed alone at the head of the periodic table. Because as the scientists are not sure where should it be placed, so in some periodic tables, it is placed separately at the head of the periodic table. Okay. Now, in my next video, I'll discuss about the group elements. Okay, that is alkali metals, then alkaline earth metals. This I will discuss in my next video. Till then, go through it. If you have any doubts, please write in the comment box. You can also refer to my email ID, that is Kasturi, Kasturi, Kasturi 74@gmail.com. You can refer to this email ID and write whatever query you have. I will reply you as soon as possible. Okay. And if you are liking the videos, press the like button, share with your friends so that they can also be benefited from these videos. And if you are a new viewer to my channel or not subscribed yet, please do subscribe and ring the notification bell, because that will notify you as soon as a new video is uploaded. Okay. And last video's link of this chapter, as well as the playlists of the other playlists, that is physics, chemistry, and biology. All the playlist link will be present in the description box. Along with it, my new channel, a new Bengali channel, has been launched. So that is regarding some spiritual knowledge. So if you are interested in that, please, you can. There is a link present in the description box. You can refer to that, and please to subscribe my channel, that channel also. Okay. Thank you so much, and have a good day.